This will display the entire content of the given data frame as output. The elements in a data frame can be viewed in two ways. One way is from the top row to the bottom row, and the other way is from the bottommost row to the topmost row. The head method is used to view the top rows by specifying the number of top rows to view. Here, to view the two top records, type df Olympic series.head 2. This function is useful while working with large datasets. Next, let's view the bottommost records. This can be done with the tall method. To view the last three records of the data frame, type df Olympic series.head 3. In Pandas, you can always view the index of the data frame. Type df Olympic series.index. The output, as you can see, displays the list of years as index values for the data frame df Olympic series. To view the columns of a data frame, you can use the columns method. This is another good approach to inspect larger datasets. Let's select the column Host Cities. Type df Olympic series host cities. The output displays all the countries that have participated in the Olympics for specific years. Let's select another column, Number of Participating Countries, and view its contents. Type df Olympic series Number of Participating Countries. The output displays the countries that participated, along with the data type INT64. Data can also be accessed and selected by its index or label location using the loc method. Type df Olympic series.loc 2012. When we pass the year as 2012, the screen returns the corresponding values associated with it. You can also select data elements with the index position using the iloc method. Let's see how this function works. Type df from df.iloc 0:2. This slices the dataset, and 0:2 indicates that data from 0 to the next two positions can be viewed. Thus, the output displays the host cities and number of participating countries, along with the corresponding year for those positions that are sliced by the iloc method. The iat method is another useful method to select an element by index position. To check how this function works, type df Olympic series.iat 3:1. This will return the corresponding data value. In this case, it's 200. Another method to select elements is through Boolean indexing. You can introduce a condition to the situation here that you want the dataset where more than 200 countries participated. This can be achieved easily by passing a Boolean expression in the argument as an object to the data frame. Let's pass the column name inside the data frame, df Olympic series, as an argument and mention the Boolean value greater than 200 in particular. The output displays the data values accordingly for those countries which have participants greater than 200 for the respective years. As a data scientist, often you will have to fix a dataset and make it ready for analysis. Missing values in a dataset are one of the most common challenges that you can possibly come across. There are several reasons due to which data can be missing or not present as expected. Shown here are a few major or common reasons for inadequate or missing data. 1. Data not provided by the source. 2. Network issues such as network or connection outage. 3. Data integration issue is a problem where a data integration process tries to fetch data from various sources but fails to integrate. 4. Software issues include issues where data encoding and formatting are also a common problem, and these are attributes of the missing data issue. Let's understand how to deal with missing values, or when a dataset holds some invalid or unexpected values. Here, for example, the first and the second series hold data values and also has some indices which are common to both the series. Please note that sum of the series is actually the sum of the data elements which have the common indices, and others which are not common got treated as not a number, or NaN. In the next screen, we'll see how to fix them and prepare a dataset for analysis purpose. This is a continuation from the previous screen. It's hard to perform any kind of computation on the dataset which contains an NaN error, and it must be fixed. There are a couple of built-in methods which can fix this problem, such as drop NA and fill NA. In a scenario where we come across NaN values, the drop NA method drops all the data elements with NaN, or not a number value. Here, drop NA S object holds data points without NaN, and you can operate on this new dataset. Thus, the output displays the indices without the NaN values. As you observed in the previous screen, the drop NA function drops the NaN values from the dataset. If you want to preserve the same dataset for further operations, this function won't be helpful. For such instances, always create a new object and use the fill NA method to replace the NaN data points with the desired value. In this example, we have filled the NaN values with 0 instead of dropping them. This is another good example which shows how to fix the dataset before performing the add operation. This example is taken from the screen handling missing values, where the second series held uncommon indices. Thus, to resolve the NaN value error, we declare a variable, fill NaN with zeros before sum, and add the first and second series in it. While adding the series, we pass second series fill value equals 0 as an argument. All the elements with uncommon indices in the second series will be filled with the value, in this case 0, before adding the two series. Therefore, all indices are held intact with no NaN value. You'll always be operating on some sort of dataset, and it can be small, large, or even big data. It's important to understand the data operation techniques so that you can analyze data properly, and this will also help in processing data faster. In data operation, you'll learn about various built-in methods and functions which Pandas provides. You'll also be able to write your reusable custom functions for data manipulation purposes. By mastering the data operation techniques, you can wrangle data efficiently and accurately. So let's learn about data operation of a data frame through a movie rating example. Let's declare a data frame DF movie rating with the title Movie 1 and Movie 2 with the ratings for Movie 1 as 5, 4, 3, 3, 2, and 1, and for Movie 2 as 4, 5, 2, 3, 4, and 2 by some viewers, which act as the index for the movies. The output shows the dataset with the viewers and how they rated each movie. In the next screen, we'll see how this movie can be graded, such as Category A, Category B, and so on, from the perspective of a viewer's choice. Declare a function with the name movieGrade. Let's say for movie rating 5, the grade is given A. For rating 4, the grade is B, and so on. Then, test it by passing rating as the function parameter. We passed 5 and it returned A, which means the function is working. Let's apply this function, which we just created, to the entire movie rating dataset created in the previous screen. Next, we use the applyMap method and pass the function movieGrade in the data frame DF movie rating. This changes the dataset from star rating to the category grade, as displayed in the output along with the viewer's name as the index. Let's look at data operations with statistical functions and how to use them. Create a data frame DF test scores for